And I will tell you this, you can use this anytime, but I want you to specifically use this when the values do not appear in the graph, okay? I want you to use Normalcdf and inverse norm when the values do not appear on your graph. If you happen to graph it and you put values along the x-axis and they don't show up, like the ones that we're asking you about, use Normalcdf and inverse norm. What does Normalcdf, what does it need? It needs a lower limit, an upper limit, like a start and a stop, so to speak, a mean and a standard deviation, and I will explain. What does it do? I'm going to use a different color for this one. It will calculate the probability of data points existing between the two values. The answer is given as a decimal. Answer is as a decimal. So multiply by 100 to get the answer as a percentage. Okay. Normalcdf needs 4 entries separated by commas. Make sure you understand that. You have to have the commas there. They're not just there to separate things on your paper. They actually are necessary for your calculator to be able to work it. Lower limit is the value that would be to the left side of the curve. Upper limit is the one that would be to the right side of the curve. And here's yet another color. Remember this, and I would have this on my study sheet right somewhere in this section. If z-scores are given, right? If I ever give you a z-score, you know that what? X is 0, like x bar, the mean is 0. And the standard deviation is 1. Okay? This is very important for you to remember because some students get stuck. You're like, Mr. Dixon, you never give us the mean or the standard deviation. If a z-score is given, the mean is 0 and the standard deviation is 1. That's just given. I don't have to tell you that. Okay? Important. All right. So let's do some examples and see how this works. Assume the mean income per household in a city, we just talked about this, I know, is $45,000 and the standard deviation is 15,000. What percentage of households earn between $32,000 and $65,000? Now notice, I'm going to use pencils because my fingers to cover up. 32,000, 65,000, do they show up anywhere? I already made our bell curve here. Do they show up anywhere, these values? They're not there. But do we know the approximate location? Yes, 32,000 would be right about here. I'm going to use a ruler. 32,000 is right about there. I'm going to highlight this later. Okay, 32,000 is right about there. And 65,000 is right about, I would say right about there. It's just approximately, right? 65,000. So we want to know the percentage of families or households that earn between these two amounts. And we can figure that out exactly, okay? So I'm going to use green for start, pink for stop, right? So we're going to tell the calculator, starting here, right, starting at 32,000, start to calculate the percentage under the curve and then stop right here. That's my upper limit. And I want everything under that curve that's found between those upper and lower limits. Okay. That's what Normalcdf is good at. So maybe right down here, if you look up on the screen, I will say this is my low, okay, this is my upper. Lower, sorry, I should have said lower limit, upper limit. So there's a start and a stop. And we can't just do, oh, 34, 34, and then whatever this is. We can't. Like there's The calculator can do this exactly, everything under this curve. Okay, so we're going to go like this, normal CDF. I need you to show me this. You can't just boop, come up with an answer. This is part of your work. Okay, and normal CDF, 32,000, 65,000. And then you tell me what the mean and the standard deviation is. Mean is 45,000. Standard deviation is 15,000. Okay? And we're going to get a number here. So grab your calculators and let's try this out. We got to press, a lot of students forget about this one. You got to press second vars. So let me show you on the screen. Second vars. What we're really accessing is distribution. See that written in blue? We're looking at distribution of data. So second vars, and don't use PDF. You want to use normal CDF. I'm only going to use CDF and inverse norm in this course. Okay? Normal CDF. So you select that, and then just enter the values. 32,000, comma, 65,000, comma, 45,000, comma, 15,000, and close the brackets. And I will write those down. So 0.7157 something. And then we multiply that by 100 if you want your if you want it as a percent, right? So 71.57% of households. This is an exact amount, right? 71.57% of households will figure that out. I want to show you right now that I was lying to you a little bit when I mentioned the 34,000. Grab your calculator. Some of you are still copying, that's fine, copy first. Let's figure out between 45,000 and 60,000. Like actually go 45,000, 60,000 as your lower and your upper and see what we get. I'm going to just go up. I'm just going to go up and copy paste. I'm going to go up to normal CDF and I'm going to change my start to 45,000. My end, my upper, this is my lower and my upper. So 45 to 60,000. I just want you to see that it's not going to be exactly 34. If you hit enter there, it's 34.13%, correct? So that's why I'm saying I'm lying to you a little bit. It's an estimation. These numbers are estimated. So it will be a little off, okay? All right, let's do another example where you don't have a start and a stop. You only have a start or a stop. And I'll show you how to navigate those ones. What percentage of households earn more than $75,000? So let's go find 75,000. It's actually, this number actually does show up here. It's right there, obviously. So we're gonna make that a green line right there. And what we want, if it's more than, right? If we're earning more, what we want everything to the right. We want all of this, right? As far as we can possibly go to the right. So there's no stop. So this is my lower, I should say. What about upper? Like, where's the upper? It doesn't tell you. Like, what are we going to put down for upper? I will just tell you, put down a really big number. Put down a really, really big number. Anything you'd like within the context. So watch this. Normal CDF. I start at 75,000. And what number would you like? A million? Sure. So I'm going to use you can go, because a million is so far to the right. So far to the right, it's not, like, you're going to make sure you include enough information, because even if you had gone 100,000, you would have been close. The answer doesn't change anymore after a certain amount. So just pick a large number. Pick large number. Question. Let's say we're in NHL. We're talking income of NHL players, hockey players, that is. And you're like, one player makes 5 million. How many players make 5 million or more? A million would not be a good pick there, right? You would have to go bigger than 5 million. You'd have to go 50 million or 500 million, you know what I mean? So it's within the context that I picked the numbers. And you know what's fun? Just go 1 and just press 0 like 20 times. That's for sure gonna make sure that it's a large enough number, okay? Anyways, the mean is 45,000. The standard deviation is 15,000. So let's do that. I'm going to call second vars, Normalcdf. I'm going to go 75,000, comma, 1 followed by 6 zeros, 45,000, and 15,000. That gives me 0.0228. If you want to round that to 4 decimals, that's fine. But if you multiply that by 100, you would get 2.28%. Either one is appropriate, unless I tell you answer as a percentage. You would want to actually go the extra step, right? All right, one more. Percentage, what percentage of households earn less than 39,000? Less than 39,000. Less, you should think of left, right? I will go up here to my previous example. More, it should tell you to the right. Sometimes it's height, taller, shorter, last longer, okay? For battery life, let's say. Okay, less. Where's 39,000? 39,000 is right about, let's say it's right about there. I want less, right? I want everything to the left. So this technically is my upper. We always come from the left towards the right. So this is upper. Can you see that on the screen there? This is upper. So we want everything to the left of it. So what about lower? Just pick a small number. So Normalcdf, I go negatives actually. In this case, I would go negative. I go negative. You want to go negative a million? Sure. So negative a million, you pick a low number. Pick low number. And then you go to your upper limit. And that's mean standard deviation. Okay. I'm going to go second vars, call PDF, CDF, not PDF. Make sure you go negative, don't go minus, negative 1 million, followed by 39,000, 45,000, 15,000. and you get 0.3446. I like the 4 decimals here because then it's easy to just shift your decimal over 2 spots, right? And you are certain to have rounded this correctly. And because it's not a dollar amount, it's okay to have more than 2 decimals. I'll do that in probability next year, like if you do grade 12 applied, I do 4 decimals as well. Okay, so you've got no lower, no upper. Okay, so I forgot that in my notes here. Can I go? I'm just going to ask you here. Upper. There's no upper, right? Question mark. Like, what is my upper? Just pick a large number. Would this help you if I go? I'm going to go over here. I'm just going to say 1,000,000 here. Like, I'm just going to say somewhere along the x-axis it's 1,000,000. Somewhere over here it's negative 1,000,000, right? You got to imagine that this goes to infinity on both ends. It goes to infinity. It's a hard concept to grasp, right? Okay. So this is normal CDF. If you want percentage under the curve, this is what you use. Okay? You good to go? I'm going to teach you the inverse norm yet. So hang in there for a bit. Take a moment and add this to your study sheet right now as well. I think inverse norm. I will just say this: second vars to access this. Right? Second vars is what you press to access this. And just make sure you add this piece, percentage of data below, that needs to be as a decimal. Okay? Percentage of data below needs to be as a decimal. So add that to your study sheets right now. Oops, sorry. And maybe put this right beside this entry on your study sheet. This is what I mean. This is your bell curve. Let's say I told you that there's a certain value here. Let's cut this right off. There's a certain value here which you're going to try to find out. And I know that 20% of data points are to the right, are above that one. So 20% of people earn more than this. Or 20% of people are taller than this, right? You do not care about this. You care about what's to the left of that value. If this is 20%, what would this be? What is all this chunk here? 80. That's right. There you go. And that is what you need. Please do not use above. You want to use whatever's to the left, so below. So I'll go below here. Below is everything to the left of that x value. And this is above here. Okay, this would be everything above it. And sometimes the problem is the question doesn't use the words below or above. It uses earns less, are shorter, right? Things like that. But then you have to kind of translate that into, oh, that means below, right? I'm below that x value. What will it do? It will calculates the actual value along the x-axis you're looking for. So if you want the height, the weight, the number of days, all of that. And here's another example of what I just talked about. remember that if the question says 35% of people earn more than $50,000 per year, that is where the 35,000, they earn more. So it's to the right of that X value, which means that this will be 65%. Earn less, right? Earn less than that value. And this is what we would want, okay? How did I come up with that? 100 minus 35. Maybe if you're not sure where that number came from, tell yourself that. Over here, I'm now no markings, but if the question says if 42% of students spend less than 15 minutes on homework, then what is that? Where would we put the line? Use a pencil. 42% spend less than 15 minutes. If the question said 50, we would say, oh, it's right here, because 50 spend less time, 50% spend more time. Where would you shift this line to? Towards the left or towards the right? Left? Yeah, you're correct. And why is that? Well, just think about it a little bit. If the question says that 42% spend less time than whatever, right, than 15 minutes, it's implying that 42% is to the left, so that means that the line has to be closer to the left, right? Because there's less to the left than to the right. There's actually now more spending more time than 15 minutes. It has to do with the distribution, right? If this had been 60% spend less, then you would want the line over here, because if you draw it there, you can tell, oh, there's like more than half to the left and the rest will be to the right. Shake, yeah, I know. Shake your head if you want, that's fine. We're gonna practice, right? This income, like, what is that? Would have 30% of household earning less than it. What income? What are you talking about? I would always encourage you to do one of these real quick, like do it on the side, and figure out where should that line be? Where should I cut this thing off? This would be 50-50. So if it's 30% earning less, it's giving you the percentage to the left. So you would say this is where the line goes, approximately. Where I have 30% of households earning less. And this is the value we're interested in. Like, what is that income? What is that income to achieve that? Okay? So we would go like this. Inverse norm. 30% goes in here, but don't put 30%. You want to change that to a decimal. Okay, 0.3. Followed by the mean and the standard deviation. We're still talking about the same question, so the mean and the standard deviation are still 45,000 and 15,000. Just write down that this is 30%, right? But you need to turn it into a decimal. So let's go and find out what this is. Clear? Second vars, inverse norm, 0.3, comma, 45,000, comma, 15,000. And there it is. This is not percentage. This is an actual value along the x-axis. So what is that? That is dollars, right? That is income. So dollars, 37,133.99. That is the income which would have 30% of people or households earning less than it. Okay? That is your answer. One more. An income of blank, this is another way of expressing this, would place a household in the top 20% of household incomes. If I say bottom 20, I think you would all know, okay, that's on the left side, right? If I say top 20, I hope that you would recognize, oh, the line has to be somewhere in here, because then it would make sense to have 20% here. And I just used 20% earlier, right? I should have used different numbers, but it doesn't matter. This is useless to inverse norm, but it's getting us closer to it. We need to figure out this part right here. We always need the left side. Inverse norm needs everything that is below that value you're interested in. You're interested in a certain income that would have, right, the top 20% would be above that. We want the 80%, okay? So we go inverse norm, 0.8, 45,000. This one only needs 3 entries. I hope you remember that. That's why your study sheet comes in handy here. So I'm going to enter this into my calculator. I'm going to copy paste. I already did a question using inverse norm. I'm just going to replace that 0.3 to 0.8. And there it is. 57,624 and 32 cents. All right, next. Unfortunately, there's not going to be a whole lot of work time today on this one. 45% of households earn less than 45% earn less than this income. Oh, sorry, earn more. My bad. I'm not reading correctly here. Earn more. So this is indicating to you that the 45% is to the right of that value you're interested in. So 45%, I would say this would make it 50-50. So I would shift a little bit over to the right, because this is not even for marks, this graph. This is just showing our reasoning, right? Like, how are we coming up with the values we need? They're giving us 45%. We want everything to the left, which is going to be 55%. So we're going to use inverse norm here. 0.55, 45,000, 15,000. I'm going to call inverse norm one more time. $46,884 and 92 cents. Okay. Okay. I'm going to say page 34 to 36. You need to at least try it, okay? You need to at least try it. When do you use Normalcdf, guys? Normalcdf is if you're trying to find a percentage, either between two values or earning more than a certain value. When you want percentage, Normalcdf. If the question gives you percentage and you want the actual value, use inverse norm. Bottom line, okay? Thank you, guys. You're great.